We are now ready for the first keynote speech of our 2022 Zero Prototype Summit. Let's welcome Mr. Dario Marrafuschi, Head of Products at Pirelli Tyre, who will discuss the integration of driving simulators into virtual tire development and how this approach leads to better interaction with automotive OEMs, more efficient product development, and ultimately to a continuously improving driving experience.
Good afternoon to everyone. Today I represent a company which has turned 150 years old this year. And before we are a brand which is well known worldwide. We have assets from motorsports to creative arts. And before talking about the next 150 years, please let me introduce a video which is showing what we are doing, what we have been doing in our history. Well, it all started in 1872 with one factory in Milan. The first passenger car tire was built in 1901, and in 1907 Pirelli won the first international competition in motorsports from an endurance race from Beijing to Milan. Today, we are a company which is operating in 12 countries with 18 plants. And let's have some snapshots of what we are doing in these worldwide in these 12 countries. So we are produce technology for electric vehicles in this transition, automotive transition. We launched a tire marking which is called Elect, which is grouping ultra-low rolling resistance tires to improve the battery range of electric vehicles. And our plan of growth sets that in 2025 we will achieve 50% more homologations for electric vehicles instead of traditional internal combustion engine vehicles. We do it with a sustainable industrial footprint because the world has changed and needs to change. And by 2025, 100% of the power supply and electricity of our factories will be provided by renewable sources. We will reach the group carbon neutrality by 2030, as well as we cover leading position in the ESG indexes and initiatives worldwide. Formula One is a great asset, and it represents our commitment and success in the high-value segment. As a matter of fact, in what we call the 19 inches and up, so rim fitting from 19 inches and up, we are leader in the market with roughly 3 times the homologations, original equipment homologations, compared to the average of the other top 4 players. Technology is not only in tires in this world, but is also in electronics. And this year, the first vehicle has been launched on the market with the full integration of the cyber tire technology into the vehicle dashboard. The automotive scenario is changing. We all know very well. Just a few facts about the changes we are seeing and the changes in the environment where we operate. So the high-end consumer products are growing year by year with a rate of roughly 7%. SUV are replacing sedan. This is not a piece of news. And electric vehicle transition is moving at full speed. What does it mean for a tire maker? It means that there is an increasing variety in the OE fitments, and also in the replacement market we see specific requests from at regional level from the countries all over the world with specific, technical requirements typical of their markets. So this translates into need for development. We have to support this need for development, and here we come to the main point, which is how we support this acceleration in development. Clearly, virtualization is the key enabler for this process. Virtualization that starts in the development phase from the virtual tire design that enables a kind of indoor virtual testing with simulations offline, and the second step, outdoor virtual testing with driver-in-the-loop simulators. The outcome of this process is that we are able to reduce by 30% the development time of our products, with the side effect, with the effect, of increasing by 30% the availability of new products on the market, allowing us to reduce by 20% the prototype costs. Not yet zero prototype, but we are on the right direction, let me say. Our plan is to develop for the original equipment. 60% of the projects that we supply that we develop for the original equipments will be engineered virtually, and all of the replacement projects will be designed virtually as well, just in 3 years' time. Today we do this with the help of static simulators, mainly focused on handling. By 2025, we will do it with dynamic simulators, looking also at the performance of NVH, clearly. Well, we set a clear milestone when we started this experience and we set these targets for the company. The milestone was 2011, when Pirelli came back to Formula One, and we interacted with Formula One teams, which were making already an extensive use of driver-in-the-loop simulations. We started that path together with our partners, and then we moved from race to road, expanding these methods of development to road cars, and the first hypercar that was developed with a strong, intensive use of driver-in-the-loop simulators for the customer was launched in 2015. So at that time, we were mainly interested in the mechanical performance of tires, of the tire models. But we soon realized that important for us is to design a tire which, to create a tire which reflects the model performances. If we invested until the time a lot of research in creating models that were behaving like a tire, we had to add one piece, which is the other perspective, creating tires that behave like a model. And here comes the concept of the digital twin, where we have a design environment where in the same design environment we create no more just a flat drawing, but a live model of a tire which, on the one hand, simulates finite element properties and then is reduced by mathematical algorithms to a driver-in-the-loop tire file. On the other hand, the same model produces all the semi-finished that goes to the factory and creates that prototype which has the same geometry and properties of the model that we have in our mind, let me say. And this reduces, on the one hand, the virtual looping, reduces the development time. On the other hand, we reduce also the number of prototypes in the factory, because we don't need anymore several iterations in the factory to achieve the proper geometry, but we do the tires in the very first room, very first building. We do it very, very close to the original drawing. So once we have this process in place, we decided to invest in this technology. We have a static simulator available in our facility in Milan. We have a collaboration with the University of Milan, the Polytechnic of Milan, where they have a DIM 400. And then we also 2 new simulator facilities will be delivered at Pirelli in Germany and in China. So what we do on all these facilities? I put some of the activities that we have in mind and we are already doing. Clearly, development for replacement and original equipment, driver training. We do internal research on advanced tire model, and I will say in a minute why we do it. We do work of correlation between objective handling and subjective handling, obviously, and we do also cyber tire development. So let's see a bit more in detail what we do. The way we see virtual tire development. First of all, we need a very close partnership with our customer, in the original equipment environments, because we work on vehicles which are not on the market, and we have to exchange models with the customer. We provide models flow from Pirelli to our customers, tire models clearly, but models as also to flow from the customer to Pirelli, so that we can work on the next generation of vehicles in-house. We exchange a clearly encrypted model, which is a very good enabler for this process. And now I go to the bottom part of the slide. This will allow us to make the typical design loop. Instead of in the real world, we do it on the virtual simulator. This squeezes the time, reduces the amount of prototypes, but is not the only accelerating factor. There is also another accelerating factor, which is the upper part of the slide, the definition of the targets for the engineers. We have from the customer a target letter, which is an heterogeneous document with target set on KPIs, target sets for the tire itself, KPIs on the tire mechanics. There are some targets which are referred to the system, vehicle and tire, with KPIs typical from the vehicle dynamics. And there are some subjective targets which are a function of the system, vehicle, tire, and driver, clearly. So this is the key point. With the use of simulators, we can translate all of these 3 kinds of targets into tire targets, Pirelli design targets. We put the driver in the loop, clearly, and we translate the subjective feelings into a real mechanical behavior for the engineers, so that we have a clear target for our team. This enables, again, accelerates our development, because it's no more a matter of chasing a subjective feeling, guessing what the tire mechanical properties should be, but we have engineered that subjective feeling. If the mechanical target, tire mechanical target, is just representative, its behavior, like in the industry, you know very well, like a magic formula can represent clearly the mechanical behavior of a tire. We think that we have to go to that step, to that goal, with physical models also. So that's why we develop advanced physical models on the simulator. Frankly speaking, these models are already available in Pirelli for offline simulations. They have to be tuned and developed to run in real time, and we think we will be very soon able to run these physical models in real time with additional information from thermomechanical behavior, let me say. Replacement lines. If for the original equipment we have to chase for the perfect fit between tire and vehicle, for the replacement is kind of the opposite. We have to produce a product line which is suitable to the whole market. So in this case, what we do is taking a vehicle, a reference vehicle, a target vehicle, or maybe, frankly speaking, more than one target vehicle from the market, and measure it with KNC test bench, create the vehicle model, in this case, not encrypted, we are creating it, and doing the same virtual loop as described before. But we add one piece. We can modify then the vehicle model that we have created to see how our product line will behave on different vehicles. Change from front-wheel drive to rear-wheel drive, change the mass distribution, and so on and so forth. You are much more expert than me in what we can change to assess if our tires will behave properly on a general purpose application. Cyber Tyre also is a very nice challenge for us, because in this case, clearly we talk about electronics, and the challenge, the use unique of simulator is to understand, investigate and understand how much the control systems of the vehicle can benefit from an information coming from a sensor in the tire. We have some activity running on this, and we think that this will be a great enabler for the ADS systems and autonomous vehicles in the very next future. So a lot of job has been done, but a lot of job has to be done still. And it has already been mentioned that the integration of the hardware-in-the-loop system and software-in-the-loop will be the next key enabler, at least for Pirelli. It is already for most of you, but it will be the very next enabler for development for Pirelli, because vehicles will be, let's say, much less mechanical and much more electronic-driven. I refer that to active steering, rear-wheel steering systems, and torque control, which become more and more complex, and the simple mechanical characterization of the vehicle might be not enough. So that's what represents our next challenge: to design for ADS system, autonomous vehicles, extending our, let's say, field of investigation, not only from handling, not only in wet handling, but also from ride and VH. So I really thanks for the discussions we'll have in these couple of days, and I thank you for your attention.
Thanks, Dario.